Hello, it's me again. 9.7 alcohols and ethers. Kind of a long one, but I'll try to be as efficient as possible. Let's see how it goes here. We just started this, trying to think, we go through different things about them. They're not too bad. There's some reactions in here that are a little tricky, but we'll try to help you out. All right, ready? I'm excited. Here we go. Okay, so let's look at some common alcohols here. You've seen these. Ethanol, you know that one. Cholesterol, you'll see that one. That's one that you will get to know when you're older because you got to watch out for it all the time. And then menthol is what's in cough drops and things like that. Also in menthol cigarettes, which none of you should be doing. So that's good. But those are all, notice they all end in ol, O-L, so that's how you know it's an alcohol. And they all have that hydroxyl group coming off of them right there. That's how you also know they're an alcohol. So let's get started with what these things are doing and how we name them and all kind of stuff. So there's three types of alcohols. There's primary, secondary, and tertiary. And all it has to do with is how many carbons are coming off of the carbon that has the hydroxyl group. So this is a primary carbon right here. It's really kind of a weird one because there's nothing coming off this carbon other than hydrogen. So but let's go to this one. This is a better one. So this right here is the carbon that's attached to the hydroxyl group. And there's one carbon coming off of that carbon. So that's why it's a primary alcohol. Same with this one. There's the carbon that's attached to the hydroxyl group. And one carbon coming off of that carbon right there. So that's why they're called primary alcohols. Let's go to secondary. Secondary probably has two. So here's the carbon that's connected to the hydroxyl group. And you'll notice there's 1, 2 coming off. Same thing with this one. There's that one. 1, 2 coming off. And look at that. Here it is connected to that hydroxyl group. 1, 2 coming off. So those are called secondary alcohols. You'll have to know these when we get into the chemical reactions, if you will. So let's see. Tertiary should be 3 carbons coming off. Here's the carbon that's connected to the hydroxyl group. 1, 2, 3. Here's the carbon. 1, 2, 3. So if there's 3 carbons coming off of the carbon that's associated with the hydroxyl group, it's a tertiary alcohol. All right, let's name some. Oh, nope, let's not name it yet. Let's do this. Let's see if you can figure out which kind this are. So what we do is we find the hydroxyl group. Oh, there's the carbon attached to it. How many carbons are coming off that? 1, 2. That's a secondary alcohol right there. Here's a carbon with a hydroxyl group right here. It's the only one that's in there. It has 1, 2, 3. That's a tertiary alcohol. And finally, look at this. Here's the hydroxyl group. There's the carbon coming off of it. It has 1 carbon coming off of it. So there you go. That's a primary alcohol. So we go secondary, tertiary, and primary. That's not too bad. Here we go. Nomenclature of alcohols. So of course the root is how many carbons there are, and the end always is an ol, like I showed you there. So this one is called methane. So we call this methanol. Kind of like that. It's also called methyl alcohol, but we're going to call it methanol right there. And this guy right here, it's got 2 carbons, so that's an ethyl group coming off of it. So that's ethanol, because it's got the hydroxyl group coming off, so it's ethanol. That's how you name these alcohols. It's not too bad, not too crazy. All right, let's name these guys with more than 2 carbons. Let's see. Here we go. 1, 2, 3. So this is off of propyl, but it's propanol. And notice it comes off the first carbon here. Not the third, but it comes off the first carbon. So what we call that is 1-propanol right here. Gave them all away there in one shot, Mr. Worth. All right, let me move this guy up here. Hang on a second. Yay! Okay, this guy, look at this guy. This is coming off the second carbon, so we call that 2-propanol. Notice, once again, numbers separated by letters by dashes. And then finally, this guy right here, look, it's not coming off it's coming off the second carbon. So you got to number this one from the right. So this one's called 2, and then 1, 2, 3, 4, 5. That's pentanol. So 2-pentanol. Spoiler alert, this guy right here is an isomer of this guy right here. And it's such a common isomer, we actually sometimes call this isopropanol. You guys know that as rubbing alcohol when you get your shots and things like that. So don't drink it. All right, here we go. Ethers. Let's talk about some ethers here. Ethers are the ones that have the O in the middle of 2 C's right there. This right here. Oh, let me move this guy. So that is the ether bunny. Hilarious. So they are frequently named by listing the alkyl groups, that's the methyl, ethyl, that kind of stuff, attached to the oxygen atom in alphabetical order and adding the word ether at the end. So put them in alphabetical order and just write ether at the end. And they're different words. They're different separate words, okay? So we look at these guys right here. Look at this. That's an ethyl group, 2 carbons. That's a methyl group, 1 carbon, coming off of that O in the ether. So notice there's the ether right there. So which one's going to go first? It's going to be the ethyl first because E comes before M. So what we call this is ethyl, methyl, ether. And that's how it looks right there. This guy right here, look at this. We got 1, 2, 3. That's propyl. Oh, 1, 2, 3, propyl. So there's 2 propyls. So if there's 2 propyls, we're probably going to use that Greek suffix for di. So we just call that dipropyl ether. And that's how that works. So something to keep in mind. When you name these things, you just name them based off of what's coming off the oxygen. Make sure they're in alphabetical order, though. All right. Physical properties of alcohols and ethers. All right. So I want to show you something real quick. I'm going to do this thing right here. There's what an ether looks like. Okay. So I know the O is kind of, it looks like it's straight when we write it down, but it actually has a little bump in here because of the bond angle. And what that shows us is that the top is different than the bottom. Okay. So it's not hydrogen bonding because this O is not connected. There's no H connected to the O. So this is actually a polar molecule. So the type of intermolecular forces that hold ethers together is dipole-dipoles, because this is a dipole right here. So if I had another one of these ether things getting together, it would be a dipole connected to a dipole. That'd be a dipole-dipole. So your alcohols have hydrogen bonding, which is stronger than this dipole-dipole. But this dipole-dipole is still stronger than your London dispersion forces, which is found in your alkanes and your alkenes and your alkynes. All right? So let's check this out. Let me get rid of this guy. Oh, he's slowly going away. All right, here we go. Let's check this out. Look at these two. They both have the same, almost the same molecular weight. But look, this one's an alcohol and that one's an alkane, all right? So that means that there's no oxygen in here. So this is nonpolar, and this has got hydrogen bonding. So I guarantee it, the intermolecular forces are stronger in the alcohol than this. How do we know? Look at their boiling points, okay? Their boiling point is way higher for the one that has hydrogen bonding and way less for the one that does not. This only has dispersion forces. When you look at their water solubility, remember water is polar and like dissolves like, right? So this would be soluble in water because it's polar. This would be insoluble because it's nonpolar. Coming on down the next 3. Here we go. Nonpolar. Ooh, dipole, and hydrogen bonding. See that hydrogen bonding, the OH right there. Anytime you see an alcohol, it's hydrogen bonding. We look at them, about the same molecular weight, about the same, but look at the difference in the boiling points. London dispersion, dipole, hydrogen bonding. It's a much stronger bond as you go up in that way right there. So, but if we look at it, look, this guy right here, not soluble in water, but both of these being polar and hydrogen bonding are both soluble in water. All right, let me move my face over here this time. Whoa! Okay, let's see what we got. Look at this guy. Ooh, look, about the same molecular weight right here. Non-polar, polar, because it's an ether right there, and then hydrogen bonding. So same crap. We got 0, 11, and 97. Once again, non-polar is insoluble in water, and these two that are polar and hydrogen bonding are soluble. Okay, that's how that works. So this is generally the thing you're looking at here. Let me hide my face for a second. So this is hydrocarbons, ethers, and alcohols. So hydrocarbons have the lowest boiling point, ethers have middle ground, and alcohols have the highest boiling point of the 3 if you're going to compare them. But their solubilities get higher as you go. Look, they both get higher. Good way to remember it. So you have that right there, okay? Let me get my face back up here. Hello, how you doing? Let's keep it rolling here. So now let's look at this guy right here. Assume you have all of these being alcohols, all right? So they all have hydrogen bonding. But as you notice, the molecular weight gets much higher as you go through, okay? Give me 1 second. All right, so apparently my daughter wanted to be in it. Now she has to leave. Get out, punk.
Bye.
Anyway, where were we here? Okay, so these are the physical properties of alcohol. So imagine all these are alcohols. They all have hydrogen bonding. But as you see, the boiling point goes up as the molar mass goes up. So that means that they still have London dispersion forces, and the London dispersion forces get greater as we get more molar mass or molecular weight. So that's what's going on there with that. But also, as they get larger, they get too big to be dissolved in water. So you can see The first three are soluble. They're small enough to be soluble in water. But then, as you see, these guys, you can only get about 7.7%. That's mass percent of water, and that's weight to weight ratio. And then here's 0.6% and 0.1%. So octanol is almost pretty much insoluble. I mean, heck, you're only getting 7% in here. These guys are like, I don't know what their percentage is. But that's what you're looking at there. What you can see is that basically fewer carbon atoms, lower molecular weight, lower boiling point, higher water solubility. More carbon atoms, higher molecular weight, higher boiling point, yet lower water solubility. Okay? So something to keep in mind. Let's look. Let's talk about which compound in each pair is likely to have the higher boiling point and the higher solubility in water. This little practice here for you. Okay, look at this. This guy's an alcohol. This guy's not. So when we're talking about, let's go through the boiling points first. Okay. So since this has got hydrogen bonding, higher boiling point. All right. You can try these on your own if you want to pause it and see what you got. I'm going to go through the boiling point first, then the solubility. All right. Now look at this guy right here. Look at this. They're both alcohols. Oh boy, both alcohols. So which one's going to have the higher boiling point? The bigger one right there. So the bigger one has the boiling point. These are both alcohols right here. These are both alcohols. But look, this one's got 2 hydroxyl groups going on. So that's like a double alcohol. So that's going to have more hydrogen bonding. So that's going to give more. That's going to be a higher boiling point. Then this guy, look, that's an ether. So it has a dipole, but this one's got hydrogen bonding. So hydrogen bonding wins. So it has a higher boiling point. All right. So now let's clear those off the table and let's do the solubility. Okay. Remember, solubility is smaller molecule and the more polar it is. Okay. Definitely polar here, the hydroxyl group. So this one's going to be the one that's more soluble in water. Let's look at these guys. Look at this. So this is a hydroxyl and this is hydroxyl. So both alcohols, but this one's smaller. More likely it's going to be dissolved in water. This guy, more polar than this guy because it has 2 hydroxyl groups versus the 1. So that one wins again. Oh, can we get the whole thing? And which one's more soluble in these? The ether with a dipole or the hydroxide group? Oh, let's count the number of the carbons. 1, 2, 3, 4 carbons. 1, 2, 3, 4. They have the same number of carbons. So I'm going to go with this one. It is definitely going to be the one that's more soluble because it's more polar than the ether. Even though the ether is polar, we have that right there. Okay, moving along. Here comes the reactions. This is good times. Now, remember how we talked about whether it's a primary or secondary alcohol? Watch what happens here. So in a primary alcohol, what you're going to do is you're going to have this guy right here, which is like a catalyst, which is potassium permanganate or potassium dichromate. And these guys will cause a 2-step process, 2-step reaction. And what's going to happen is they are going to remove that hydrogen, and they're going to make a little double bond there, which we have essentially made an aldehyde. Remember that? I don't know if you remember that functional group. We make an aldehyde. Then what happens is it'll actually add another oxygen in there and make a carboxylic acid. This is a carboxylic acid. It's got the carbonyl group next to a hydroxyl group. So it makes a carboxylic acid. So if you have a primary alcohol and you mix it with these catalysts right here, they will actually make a carboxylic acid right there. Something to keep in mind. So it goes through a 2-step process and makes that right there. Okay. What if it's a secondary alcohol? Well, let's talk about that. Same exact catalyst, but what we're going to do is we're going to only do 1 step, and we're going to just remove the 2 hydrogens, and we're done. But notice it's in the middle of the molecule, the R's and R's. That means like a chain can go that way or a chain can go that way. Just a chain of carbons, if you will. So there's going to be a carbon here and a carbon here. And since that makes a carbonyl group in the middle, we call that a ketone. Remember I told you it was in the middle of the alphabet, so it's in the middle of the molecule. So when you have a secondary alcohol that's surrounded by 2 carbons right there, it'll make what we call a ketone, all right? That's different than a primary alcohol. Those made carboxylic acid, all right? Let's keep it rolling here. Tertiary alcohols, they don't oxidize. So if you ever see a tertiary alcohol and you have it mixed with, let me go back, with these 2 guys, you just say no reaction. Nothing's going to happen, okay? Let's see. Let's go with some examples here, okay? What kind of alcohol is this one right here? Ooh, looks like a primary alcohol, doesn't it? Sure does. So a primary alcohol is going to produce an aldehyde and then a carboxylic acid. So watch what happens here. We're going to remove this hydrogen and this hydrogen, and then we're going to, that'll make the aldehyde, and then we're going to insert a new little oxygen in there, and that's going to make that hydroxyl group coming off of that carbonyl group which makes carboxylic acid. All right, we're gonna learn how to name these in some other lecture. I don't know when it is, but we'll learn how to name those. All right, how about this guy? There's your carbon right there connected to their hydroxyl group. And look, it's got a carbon here and a carbon here. So that's a secondary alcohol. So it's going to be a one-step problem, and it's just going to make a ketone. So there's what your ketone looks like right there. You got a carbon double bonded to an O in the middle of two other C's, and that's why you call it a ketone. So that's how it works. Some of the questions I've seen you guys be perplexed with, or that you might get asked in your homework or your test, is they try to tell you what kind of alcohol is going to be formed if we form this after the reaction. So let's look and see what we got here. We formed a ketone, right? So that's just going to be a secondary alcohol. So since it's a secondary alcohol, this carbon right here is going to change this into an OH, and that's all there is to it. Boom, right there. So that's the thing that forms because we knew it was a primary alcohol because it formed a ketone, all right? The other type right here, if you look at this, look, there's your carboxylic acid. So we knew that this alcohol was a primary alcohol, which means that this carbon is going to be to a hydroxide right there, but it's going to have only have hydrogens coming off the other way. So the hydroxide gets formed here, and then the hydrogens come off. So you can see there's your hydroxide coming off of that O that was in the carbonyl group, and then your two hydrogens here. Notice we got rid of this hydrogen to form this guy. So because the forward reaction would produce that oxygen. That's how it works. Okay. Acid catalyzed dehydration of alcohols. This is we've already done this. What we've done before is we went this way. We went from right to left instead of left to right. So we went right to left before when we had alkenes and we added water to it. We just had a hydrogen and a hydroxide added to it. Now we're just going to take them away. So we're going to take these two things away, and you'll notice it forms two H's and an O. There's your water right there. And what we'll do is we'll get rid of everything here, which allows these two carbons to bond to each other, which makes that alkene right there. So if you are looking to dehydrate an alcohol, it will just form an alkene, all right? Something to keep in mind, all right? Let's look. You got this guy right here. Look at this. So this is the hydroxyl group right here. We're going to remove that and a hydrogen. You could either remove this hydrogen, and the double bond would form here, or you can remove this hydrogen and the double bond would form there. It just depends. It's random. Who knows which one's going to happen, but it can happen. Just know that it could be either side of the hydroxyl group right there. Okay? Hey, that's it. 9.8 in the book. That was 17 minutes long. I deeply apologize. I went through it as quick as I could, but you might have to take good notes on it and see what you got, all right? Miss you guys. Have a good rest of your day.